So here's problem number 49, and it is a telescoping series problem. What does that mean? Well, first of all, it means that we're going to take this problem and we're going to break it down using partial fraction decomposition. So we'll start with saying 6 is 2n minus 1, 2n plus 1 is equal to a over 2n minus 1 plus b over 2n plus 1. We remember how to do partial fraction, right? So this is 6 is equal to a times 2n plus 1 plus b times 2n minus 1. Everyone okay with that?
Yeah.
So let's make n equal negative 1/2 to start out. If we put negative 1 in here, negative 1/2 in here, we get a 0, and we end up getting left over that 6 is equal to b times 2 times negative 1/2 minus 1. So that is negative 1 minus 1, that's negative 2. 6 is equal to negative 2b, or therefore b is equal to negative 3. So far so good? Let's do it again. N is equal to positive 1/2. When we do that, we get 6 is equal to a times 2 times 1/2 plus 1. And when we put the positive 1/2 in there, the b goes away. I chose 1/2 so that b would go away.
I know, but you put n.
Well, when I put n here, I get
Oh, never
0
mind,
times
okay.
b. The
No.
b does go away.
Okay, never mind.
That's all right. This is 1/2 times 2 is 1 plus 1. This is 2a, or a must be equal to 3. That means that this series can be rewritten as the series of, and I'm going to write it 3 over 2n minus 1 minus 3 over 2n plus 1. Isn't that great? Yeah, that's great. Now, the deal with the telescoping series is that as we start to build the series, we're going to get a bunch of cancellations, and something really nice is going to happen. So I could start by asking the question, what is the first partial sum for this series?
Starts at n equals 1.
Starts with n equals 1, and it's going to be 3 over...
It's 3 minus 3. No, it's 3 minus 3 fourths.
Okay, 3 over 2 minus 1 is 1, minus 3 over 2 plus 1, which is
3.
3.
So it's
3 minus
No, no,
1.
no, don't cancel, or don't simplify, all right?
Oh, okay.
I want to look now at what the second partial sum is. Well, it's 3 over 1 minus 3 over 3, plus, now I'm going to make n equals 2, and I'm going to add the second term. And I'm going to get, in this one, 3 over 3 minus 3 over 5.
Okay.
And now I'm like, oh, look at that. Those two are going to cancel out. Isn't that great? Let's look at the third partial sum.
3 over 1
3 over 1
minus 3 over 5.
minus 3/5. And now let's add the third term in there. It ends up being plus 3/5 minus 3/7. Oh, look at that. Those middle terms cancel out again. Does anyone have an idea
It's the
what the nth partial sum is going to be?
3 over 1 minus 3 over 2n plus 1.
And isn't it generally like you don't even have to write it out? It's always going to be the same as long as you.
Well, I like to write it out to make sure that you understand where we're coming from.
But I'm
Now,
saying it goes every time.
are you ready for the last piece? That's what the nth partial sum is. A reminder in big blue that S, the sum of the series, is equal to the limit as n approaches infinity of the nth partial sum,
So it'd be 3.
which is the limit as n approaches infinity of 3 over 1 minus 3 over 2n plus 1. And when we apply that limit, the second term, what happens to it, Ethan?
Equals 0.
And indeed, leads to 3. So, and all the telescoping series do exactly that kind of thing. They have lots of cancellations, and all that matters is something from one of the beginning terms, and all the other stuff goes away. Yes, gotcha.
Yeah, oh, so that's what you're saying. So if you figure out what the first number equals to, like in that series, so not like S1, but like...
I could be wrong. It could be like, right now, like this one had two parts in the partial fraction decomp. There could be 3 parts and only 2 of them cancel, or 1 of them cancel. There's going to be some cancellation, right? But that's how we do those problems, and they all take that sort of same flow. Eric, this was your question. Are you satisfied with that answer?
Yeah, I'm satisfied.
Very good. Let's close off the recording and let's get to the new stuff, because the new stuff is cool with a K.